Okay, so chapter 5, this is for exponent. So x to the first power is usually when the exponent here is 1, okay? When the power over here is the first power, we omit the 1 over here, we just put x over here. Now, x to the third power here, that means x multiplied itself 3 times. So this number up here is called the exponent, and that indicates how many times this base over here multiplied by itself. Now, -5 to the second power, whole thing in the parentheses is a base, so which indicate that the -5 multiplied itself twice, okay? So the result here is what?
25.
Possibly 25. Now, what about this one over here? This one here has no parentheses. The exponent only apply to this number, 5. Doesn't apply to this negative sign. So apply to only 5. So this negative sign is going to stay here. So it's going to stay. And then you're going to multiply this 5. So the result here will be -25. You see the difference between this one and this one. This one has parentheses, this one doesn't. So the base are different.
If it was -5 to the third power, would it be negative again?
Yeah, it will be negative again. Yeah, good observation.
The even numbers are negative and the odd would be positive?
You got it. Good. Okay. Good job. Okay. So if you have a negative base here raised to the even exponent, the result turn out to be positive, because negative times negative is positive. But if it's to the odd power over here, odd exponent over here, then you multiply another negative factor, the result will be negative. You got it. Okay. Good observation. Now, what about this one? What is the base for this exponent 3? So repeat to multiply this x 3 times. The 6 here this exponent has nothing to do with this 6 right here. So the 6 is going to stay, and you multiply x here 3 times. Over here, the base is the whole thing inside the parenthesis. So you're going to multiply x minus 7 twice. What about this one? What's the base for this square over here? Now let's try to discover some rule for exponent. When you multiply a squared with a to the third power, okay? A squared is a times a. Now you multiply with a times a times a, which is a cubed over here. That's a to the what power over here?
Fifth.
A to the fifth power, okay? Now you observe that when you multiply two factors, and what happened when they have the same base, then what happened here is you're going to repeat to multiply this 5 times over here, because this is 2 times, this is 3 times, so altogether 5 times. So this one here is a sum of these two exponents, providing that they have the same base over here. Okay? So this is called the product rule for exponent. Okay, you guys just discovered that. So when you multiply these two, when they have the same base, you keep the base and you add the exponent. Okay. So they're kind of like co-worker. They're side by side, okay? And then you add the exponent over here, okay? Notice that this doesn't apply for addition or subtraction. So only when it's multiplication, okay, in between. Mm-hmm. For example, if it's a squared, okay, for over here, a squared times a cubed, it is a to the fifth power. Mm-hmm. However, a squared plus a cubed, you're not able to combine them. Okay? This is not multiplication, and also they are not 9 term either, right? Okay. Mm-hmm. Okay, let's do this one. Okay, so they all have the same base and multiply here. So we will keep the base and add the exponent. So that's y to the what power? Yeah.
Oh, don't forget the 1. Okay.
Y to the first power here.
10 altogether.
Yeah. So that's why it is, don't forget that one.
Gotcha.
Okay, remember to the first power, you omit y the 1 there, right? Okay, so that's the first power. So it is y to the 10. Now, what about this one over here? So we're going to combine this two. So combine a to the 14 power times a to the 10 power. What do you get?
24.
-5 times a to the 24. Okay. Okay. Now what about this one over here? 2 to the third times 2 to the 7th power.
To the 2 to the 10.
Yeah, you got the job. Okay. 2 to the 10 power. Notice the base here doesn't change. Okay, the base don't change, because you see what happened over here. You multiply them, right? So the base stay as a right here. Mm-hmm. You only add the exponent. Now we're going to discover another rule. So let's think a to the third power and then square there. Okay, put them inside the parenthesis. So we're going to multiply a cubed with a cubed. It's actually the 3 plus 3, which is the same as 3 times 2 over here, right? So the 6 here is relating to this. Okay, how many times this 3 adding itself? Well, will be 2 times, right? So 2 times 3 makes 6. So this exponent here relate to this exponent and this exponent. Now, this is called power of a power rule. This is a to the m power, okay? And now this whole thing raised to the n power. So we call that power of a power, okay? And what do we do over here? We multiply the exponent. And sometimes, and to make it easier for you guys to remember this, I make up this slogan when you go on strike, okay? You show people you have more power, say, power of a power. We multiply our powers, okay? So, over here,
So cute.
to remember this rule. So I finally had to come up with something to help you remember. Okay, so power of a power rule. So take a good look. This is power of a power. Okay, so remember that. Okay, now 3 square, 3 to the second power, now raised to the fifth power. What does it equal to?
3 to the 10th power.
3 to the 10th power. Good job. Okay, so 3 to the 10th power. Okay, what about this one? Yeah, first thing we do the parentheses first, right? So simplify inside. So this is side by side, kind of like coworker. That's side by side. So you keep the base. When they multiply here, they're the same base. You keep the base and you add the exponent, right? So this is x to the what power inside? X to the
5.
the fifth power. Yeah, you got it. Yeah, good job. Okay. Right. Now this is power of a power, right? And this will be x to the what power. I used to mix it. If a student make a mistake, I make them look and raise their hand with me. Okay. Okay. Now what about this one here? First, we have to simplify this one first, okay, and simplify this one, and then later multiply, right? Exponent before multiplication, right? Okay, so this is x to the what power over here?
8th power.
8th power, good job, okay. And then the second one, it will be x to the
6th.
6th, okay. Now over here, at the end, this is x to the what power?
14.
So 14. Yeah.
Yes, because they're side by side. This is not power of power. Okay, x to the 14. You keep the base here, you add the exponent. Okay, now what about this one? Now let's try to discover another rule. So a to the fifth power divided by a squared over here. Now this up here is a times itself 5 times. Down here a times itself 2 times. So a over a is 1, a over a is 1. So this 2 cancel. Okay. So leaving you with this 3 factor of a survive. So this is a to the third power, which is this 5 subtracting this 3. So 3 factor, so before you have 5 factor of a, now you cancel out 2 of them, you have 3 factor of a survive. So 5 subtracting 2 over here, right? Okay. So this, in general, is 2, okay? This goes with the quotient rule. So a to the m power divided by a to the m power, that's a to the m minus m power. So when you divide, them when they have the same base, you keep the base and use the exponent on top, subtract the exponent down here. Okay. When you multiply, you add the 2 exponents. When you divide, you subtract. Okay. Okay. Now try this one. What does it equal to?
6.
A to the 6. Okay. A to the 6. You got it. A to the 6 power. Okay. So you keep the base and you subtract the exponent. So that's 6. Okay, now try to discover this one, I think. A times b to the third power. Well, this whole thing inside the parenthesis is a base. So ab times itself 3 times. Well, remember multiplication is associative and commutative. So you can actually switch the order. So I can put all this a multiplied together, all this b multiplied together. So at the end, this will be a to the third power times b to the third power right here, right? Okay. So in the future, we can go straight from here to here, okay? Because now it looks like when it is multiplication inside, when you have a product inside, this exponent is going to apply to each factor, okay? So you get AQ and then BQ, AQ times BQ, right? Okay. So this is called power of a product rule, okay? So when you have this power of this product, then what happens here is you're going to use this, the power over here, the exponent here is going to apply to each factor. So apply to A, you get A to the N, and then you times, then apply to B, you get B to the N, okay? So power of a product, okay? It has to be multiplication in between here. Now notice this is not for addition or subtraction. So if it is addition in between them, then you cannot just apply the power to each term over here, okay? This is not equal to this. in the past, I had students do this mistake, and then I had to give them example of money. Okay, so for example, $1 plus $2 is equal to one, and then raised to the second power, is it $1 squared plus $2 squared? If it is, then what happens? Okay, so 1 plus 2, it is 3. 3 squared is 9. Now 1 squared is 1, 2 squared is 4, 1 plus 4 is 5. 5 is certainly not equal to 9. So they're not equal. So if you make that mistake, so you're going to owe me some money, okay? So I could give you $5 and then you're going to give me $9, right? Okay. Okay, so only for multiplication in between, you can apply this power to each factor, okay? Okay, the next one here. What about this is, if this is like a division. So over here, it is multiplication. You can apply the power. What about when you have a division? Okay, so the base over here is A over B. So we're going to repeat A over B times itself 3 times. Now we can multiply across, right? A times A times A give you A cube. Down here, B times B times B give you B cube, right? Okay. So notice that when you have division over here, this power also applies to the numerator and the denominator. So you can just apply to A cube, apply to B cube, okay, and the A stay on top and the B stay down here, okay. So that's called the power of a quotient rule. So A to the M power, A over B, parentheses to the M power is A to the M power over B to M power. Now let's try to do this example, this exercise here together. Okay, the first thing we do here, it is we want to simplify inside the parentheses first. Okay, simplify the inside here. We will have this -6 divided by 2. We'll get what? Negative 3. Yeah, you got it. Okay, so we got -3 over here. Okay. Now this one over here. It is a quotient, so we can apply this power of a quotient rule. Okay. So we'll apply this power to this numerator and also apply the power to the denominator. Okay. Now up here, in between this is multiplication, right? So it is a product, okay? So use the power of a product rule. So I'm going to apply this square to the -3, also apply the square to x cubed. Okay. And finally, the square of -3, it is positive 9. And the square of x cubed, we use the power of a power rule. So that's x to the 6th power, right? And then this one here is y to the 8th power, right? So do you notice that there's a pattern? So over here, when you have division and multiplication between them, only division and multiplication between them, then yes, the exponent over here is going to apply to each factor in the numerator and also the denominator. Okay, so in the future, and then you can go ahead and apply this square to -3, you get positive 9. Square of x cubed, you get x to the 6. Square of y to the 4th power, you get y to the 8th power. Okay. Okay, now I'm going to summarize. Okay. Am I going too fast for you guys? Oh, summarize this. Okay. So when you have a to the m times a to the n, when they have the same base and multiply, you keep the base over here and you add this to exponent. And when you divide over here, when they have the same base, you keep the base, you subtract the exponent. Exponent on top, subtract the exponent down here. Okay. And when you have this power of a power, a to the m power and then raised to the n power, you multiply the power. We multiply the exponent. Okay, so a to the m times the n. Okay. Now, when you have a times b raised to the n power, when this is multiplication in between them, the power applied to each factor. So it's a to the n power times b to the n power. And this is division over here. Then this exponent also applied to the numerator and the denominator. So it's a to the n power over b to the n power. Okay.